Students, let us start with our exercise 2.3. I hope the remainder theorem as well as the factor theorem I have proven for you. Now you are clear with that part. So application parts of these theorems now we are doing in exercise 2.3. So first question, alternatively I am picking, suppose your part number 3 or 4. So third part, you need to check the polynomial given to you is, that is x raised to the power 4 plus 3x cube plus 3x square, then it is plus x plus 1. This is the polynomial given to you, and the question is check whether x plus 1 is a factor or not. So if x plus 1 is the factor, then I told you it is divided by x plus a, means p minus 1 should be equal to 0. So if x plus 1 is a factor, then I have to check whether p minus 1 is equal to 0 or not. On behalf of this solution, I have to answer the question. So here you find your p minus 1. So what is that equal to? Minus 1 raised to the power 4 plus 3 into minus 1 cube plus 3 into minus 1 square plus bracket minus 1 and plus 1. So whenever negative base is there and power is even, result is always positive. Here plus into minus, because I know this will be minus, because power is odd, base is negative, it will remain 1, and into 3 will make it minus 3. Here again even plus, so this will be plus 3. Here it is minus 1 and here it is plus 1. 3 minus 3, 1 minus 1. But your remainder p minus 1 is equal to 1, which is not equal to 0. So therefore your x plus 1 is not the factor of px. So please be clear with this, very important from the examination point of view. So you have to continue with the same in class 10 also. So please keep a check. If anything you are finding difficult, please put the queries. So that is your third part. Now let us see what is the fourth part. Polynomial given to you is, now in fourth part it is given x cube minus x square, then minus 2 plus under the root 2 into x plus under root 2. Again you need to check if x plus 1 is the factor or not. So again I have to substitute x by minus 1. Let us see what happens for this particular case. Minus 1 cube minus 1 square, then it is minus 2 plus root 2 into minus 1 into minus 1. Wherever x is there, you have to replace by minus 1 simply. Make it a rule there. So now if this calculation gives me p minus 1 is equal to 0, on that behalf I can say that x plus 1 is the factor of this. Let us see. Again this will be minus 1, minus plus, plus into minus, minus 1, and then here it is minus 2 into minus 1 will be plus 2, minus under root 2 into minus, again plus under root 2, and here again it is plus under root 2. So please do it very carefully. X plus 1 will be the factor, means p minus 1 should be equal to 0. So what happens here? Minus 1 and 2. This becomes 2 root 2 again, which is not equal to 0. So hence x plus 1 is not the factor of this. Keep a check upon your signs everywhere. Here I hope you understand. Minus into minus will make it plus. So this will remain 2 plus root 2, but minus 1 minus 2 plus 2 will go off, and these two root signs, that is under root 2 is of plus sign here. So this will make it 2 under root 2, which is not equal to 0. Hence this is not the factor of this fourth part also. Then in question number 2, use factor theorem to determine whether gx is a factor. So any one part, same thing is there. So if gx is the factor here in question number 2, suppose I am taking the second part here, question 2, second part. What do you need to prove? What is the px given to you? Px, the polynomial you have is x cube minus 4x square plus x plus 6. And what is gx? Gx is x minus 3. So if x minus 3 is the factor of px, so this implies x minus a means pa. So p3 should be equal to 0. So if this is coming, p3 coming equal to 0, then I can say gx is the factor. So what happens here? p3, let us see, this will be 3 cube minus 4 into 3 square plus 3 plus 6. 3 cube is 27, 3 square 9 into 4 is 36 plus 3 plus 6. 27 plus 3 30 plus 6 36 minus 36, which results into 0. So P3 is equal to 0 you are getting. Hence you can conclude that Gx is the factor of Px. So this is again the application of your factor theorem. So remember, always will be equal to 0 if your Gx is the factor of Px. So that you have to remember forever. And these all are the applications of your factor theorems. Means in factor theorem, your remainder will always be equal to 0. So third question, again this is a very important question, that is the application indirectly of your again factor theorem. And read the question very carefully. Suppose I am taking third question, the first part for you. Px given to you is 2x square plus kx plus under root 2. What else is given? X minus factor. So given x minus 1 is the factor of px, What does it mean? If x minus 1 is the factor of this polynomial, so this implies p1 is equal to 0. p1 is equal to 0. So then I have to find the value of k. So therefore p1 means 2 into 1 square plus k into 1 plus under root 2 will be equal to 0. P1 means then I will replace x everywhere by 1. That will give me the P1 and is equal to 0. So 2 into 1 square 2 plus k into 1 k plus under the root 2 is equal to 0. So what will be? K is equal to minus, or you want to take minus common, so you can write minus 2 plus root 2. So this will be the answer for your first part. So finally you can substitute this value and you will find that P1 will become equal to 0. For what value of k? Your x minus 1 is the factor of this. And then randomly I am picking one more part for you. Suppose I am picking third part of the same. Second you can try of your own. So in third part, if you see for the same polynomial, then again I have to particularly check whether P1 is equal to 0 or not. But now polynomial is kx square minus 3x plus k. It is given kx square minus 3x plus k. For this polynomial, I need to check whether kx minus 1 is a factor of this. Again, I have to check p1. What is p1 for this? Is k 1 square minus 3 into 1 plus k again is equal to what? 0. K into 1 square k minus 3 into 1 minus 3 plus k and is equal to 0. So what happens here? 2k. This is equal to 0 plus 3. 2k is equal to 3. So k is equal to 3 by 2. So your answer will be 3 by 2. So that you can check. If you substitute here 3 by 2 and here also 3 by 2 and then you do the calculation, for x is equal to 1, you will be finding the result becoming equal to 0. But no need to go for that. You have to simply find the value of k. So I think that much is sufficient for today. You do practice of question number 1, 2, 3 and all the parts I say. Then fourth question is a question based upon some factorization, and this is a new method which I will add to your knowledge tomorrow. Till then please sit and do revision of all these questions. of exercise 2.2 as well as exercise 2.3. Please take your time and then we will start with question number 4 tomorrow. Thank you.